So we do need to go back and we need to rehash a theory of acid and bases that we would have covered in a general chemistry course, but didn't really show up that much because it didn't really matter for general chemistry. And this is the idea of Lewis acid-base theory. Now, you probably learned about the Arrhenius and the Bronsted, and you may have had a Lewis address depending on who you had, but you typically didn't talk about with general chemistry because they don't work a lot with Lewis structures. So to recap, an Arrhenius acid base, an acid is one that produces H plus by dissociation of water, and a base is one that produces OH minus by dissociation of water. And that's your Arrhenius definition. It works well for a lot of inorganic acids and bases. The Bronsted definition says that an acid is a proton donor, whereas a base is a proton acceptor. And this works, again, well for inorganic acids. But when we start doing organic chemistry, we're actually going to focus more on the Lewis. And the reason why we look at the Lewis is because organic chemistry is going to focus a lot more on the electrons. So, at its heart, a Lewis acid is a lone pair electron acceptor. So what it does is accepts 2 electrons from a lone pair on an atom to form a bond. Whereas a Lewis base is something that gives off 2 of its lone pairs to form a bond. So, an example of this you're probably already sort of familiar with. If we have water, we have H+. It's obvious that the H+ here is an acid. You know this from your Arrhenius definition. So what makes it an acid under Lewis theory? Well, what will happen is that water will take these lone pairs and it will form a bond with the H+. And this is how we end up getting the hydronium ion. So here, water is acting as a Lewis base because it's taking its lone pairs and it's making a bond by donating them to the hydrogen. And the H+ is acting like an acid because it's accepting those lone pairs to form a bond. So why does this become important? Well, a lot of chemistry in terms of organic is basically Lewis acid-base theory. So if we look at something like bromine or bromine ion acting on something like methyl iodide. And we want to describe how this reaction occurs. Well, it's a simple substitution reaction. So we end up getting the bromine, or the bromide, attached to the methyl, forming iodide. But how does this work? Well, what bromine is going to do is it's going to act like a Lewis base. It's going to take this lone pair, and it's going to kick it off. Iodine is going to act like a Lewis acid in that it's going to accept electrons from the carbon. And so we end up getting this complete octet, these lone pairs on iodide because it accepts the electrons from carbon. Now this is all being done in conjunction, but here you're starting to see where this is the power of the Lewis acid-base theory. It's explaining a lot of the driving forces here. A base creates bonds from its lone pairs, and acid either will create bonds by accepting those lone pair electrons, or in this case of iodide, it'll use them to create a lone pair. So, quick and dirty on Lewis acid-base theory, but understand that a lot of the reactions that take place under organic chemistry are actually just considered acid-base because of how this theory is formulated.